In the previous videos, we looked at the motion of objects moving in one-dimensional space in terms of displacement, velocity, and acceleration. The objects were moving in either horizontal motion or in vertical motion. In this video, we will examine the movement of objects with both horizontal motion as well as vertical motion, that is, motion in two-dimensional space. Examples of these include a basketball throw, a flying arrow, a kicked football, a car jump, or athletes doing the long jump, just to name a few. Such motion, where the path of the object is parabolic, is called projectile motion. It was actually Galileo who first accurately described projectile motion, and he showed that it could be understood by analyzing the horizontal and vertical components of the motion separately. The analysis of objects in projectile motion is not concerned with how the object is thrown or projected, but is only concerned with its motion after it has been projected, and is moving freely through the air under the action of gravity alone. Thus, the acceleration of the object due to gravity acts downwards with a magnitude of 9.8 meters per second squared and is assumed constant. Although air resistance is often an important factor, in many cases its effects can be ignored, particularly if the object is heavy or moving at low speed. For simplicity, we will neglect air resistance in the analysis of projectile motion for the time being. To begin with, consider the following clip. If you were to observe the motion of the bomb as it falls, which path of motion would you see the bomb most closely follow relative to you on the ground? To answer the question, we need to understand and analyze how the bomb or any object behaves when moving horizontally as well as vertically under the influence of gravity. Let's begin to analyze the motion of a projectile. Consider a cannon shell being fired from a cannon as follows. For convenience, we'll define the motion to begin at time t equals 0 at the origin of an xy coordinate system such that the initial x position is at 0 and the initial y position is also at 0. We see that the shell is fired with some initial velocity, which we shall designate as VO, and at some initial angle which we'll designate as theta O. We can separate the initial velocity vector into its horizontal and vertical components using basic trigonometry, so that the initial velocity will have an initial component in the horizontal direction, which we shall call Vxo, and an initial vertical component, which we shall call Vyo. Now let's have a look at these individual components as the projectile flies through the air along its parabolic path. As the shell flies through the air, it experiences an acceleration due to gravity pulling it down and thus slowing its upward motion. So the vertical component of the velocity decreases until the shell reaches some maximum height. After this, the projectile begins to fall and increases its vertical velocity in the downward direction. At the same time that there is vertical motion, the shell is also moving in the horizontal direction due to its initial velocity in that direction. Because there is no acceleration in the horizontal direction, remember that gravity only acts in the vertical direction and we're ignoring air resistance, so there is nothing to slow or speed the shell along the horizontal, so its velocity along this direction remains constant. The velocity of the shell at any point in time is a vector sum of the vertical and horizontal velocity vectors at that point in time. So we can see that the overall velocity decreases as it reaches its maximum height, then increases again. This change in velocity is caused purely by the change in the vertical component of the velocity. Which of the following statements is true for a projectile launched at 45 degrees with the horizontal? A projectile is fired upward at 45 degrees to the horizontal. What do we know about the vertical component of the speed after the projectile reaches its maximum height? What do we know about the vertical component of the acceleration after the projectile reaches its maximum height? In summary, projectile motion occurs when an object is moving in one direction along the horizontal plane as well as having motion in the vertical plane. The vertical motion experiences gravitational acceleration, causing the object to move in a parabolic path. The horizontal and vertical components of the motion can be treated separately as one-dimensional motion in the horizontal direction and in the vertical direction.